You are welcome to another video of Juniper Security Associate course. In this section, I will talk about Juniper SRX Static NAT configuration. A static NAT is a one-to-one mapping between two IP addresses, a private and a public IP address. A static NAT has highest priority in NAT policies, and it is bi-directional. It means it translates the source IP address of the traffic like source NAT when the traffic is initiated from the private IP address, and it translates the destination IP address of the traffic like destination NAT when the destination of the traffic is public IP address. As I said in the introduction, a static NAT is a one-to-one mapping between two specific IP addresses or between two subnets with equal number of IP addresses. If you remember in Juniper SRX traffic flow, a static NAT has the highest priority among all other NAT policies, including source NAT and destination NAT, and even before routing decision and security policies. In other words, if an IP address in the packet is matched with both destination NAT and static NAT, or both source NAT and static NAT, static NAT translation will be applied to the IP address. As an example, in this topology, a one-to-one mapping is created between two IP addresses, 192.168.10.10 and 12.1.1.10. It has the highest priority even though 192.168.10.10 matches both source NAT and destination NAT. A static NAT is bi-directional. It means when the traffic with the source IP address of 192.168.10.10 is coming from the inside zone and is forwarded through the Juniper SRX, the IP address will be translated to 12.1.1.10. It also applies to the traffic with destination IP address 12.1.1.10 coming from the outside zone, which will be translated to the IP address 192.168.10.10. This is the topology that we will be configuring a static NAT in this section, and this is exactly the topology that we used in the previous sections. Users inside the network with IP address subnet 192.168.10/24 are connected to the internet through two interventing devices. We have a server with IP address 10.118 and SSH server enabled in the inside zone. Although source NAT and destination NAT are already configured in the Juniper SRX, we can configure a static NAT without paying attention to the current configuration of source NAT and destination NAT, since a static NAT has the highest priority. What we will configure is to create a static one-to-one mapping between two IP addresses, 10 and 118 in the inside zone and 120 in the outside zone. As you can see in the figure, a static NAT applies in both directions. It translates the source IP address of 10.118 to 1.120 for the traffic forwarding from inside zone to the outside zone. It also translates the destination IP address 1.120 to 10.118 for the traffic forwarding from the outside zone to the inside zone. This is the configuration that I have prepared for a static NAT. For the configuration of a static NAT, first we have to enter inside the context of security NAT static. Then we configure a rule set with as many rules that we need. Here I have a rule set with the name of static NAT and only one rule with the name of 10.118 to 1.120. The rule set is applied to the traffic coming from outside zone. Outgoing zone or interface cannot be configured since static NAT processing is done before routing decision, and at the time of NAT processing, the outgoing interface or zone is not clear. In the second line, the traffic with destination IP address 120 is matched. It is also possible to match traffic for a specific port number, but here I will match all traffic with 120 as destination IP address. In the last line, the equivalent IP address in the inside zone 10.118 is configured. Now you know that proxy ARP also needs to be configured because 120 is not physically configured in the Juniper SRX, and by default Juniper SRX does not reply to the ARP request for that IP address. In the last line we configure proxy ARP for this IP address, and this is the complete configuration that we can copy and commit in the Juniper SRX. Paste and then commit. To enable live monitoring of the log file, we enable it using a monitor start command for the file firewall and only for port SSH or 22. Then we created traffic from outside zone to the destination IP address 120 and destination port SSH 192, 168, 120 and destination port SSH. The output of log file shows that the destination IP address 120 is translated to 10.118. It also shows that the traffic match with the static NAT rule with the name of 10.118 to 1.120 and security policy with the name of permit all. It also can be confirmed with monitoring session table with the command show security flow session and then grep/22. The destination IP address of incoming traffic is 120 and the source IP address of return traffic is 10.118. So it is confirmed. We can also check the configuration and also static NAT translation hit with the command show security NAT static rule and then all. As you can see, translation hit and successful session is 1, and this is the configuration one-to-one mapping between these two IP addresses in the static NAT. As I have explained earlier, static NAT is bi-directional. To see bi-directional capability of static NAT, we send a traffic from inside zone with the source IP address of 10.118 to the internet, for example, to the Google website and destination port 80. We expect that the source IP address will be translated to what is configured in static NAT and not to what is configured in source NAT. Before sending traffic, we start live monitoring of log file for the destination port 80, run monitor stop, and again start firewall and grep port 80. Then we send traffic to the Google with the port 80. The output shows that the source IP address 10.118 is translated to 120, and it means it matches with static NAT rule, which is displayed here 10.118, 120, and it is also matched with the security policy permit web. We can see also the same result the session table with the command show security flow session, and only for grep port 80. I'll send again the traffic. As we can see, the source IP address 10.118 is translated to 1.120. The source IP address of incoming connection is 10.118, but the destination IP address of return traffic is 1.120.